this is the counting and probability part of the course, and what we're going to do here is look at some counting and number of options type questions. So the code to open a combination lock is an ordered sequence of 4 digits chosen from 1, 2, 3, 4, 5 and 6. How many codes are possible if repetition is allowed and repetition is not allowed? Sorry, let's just move into that first off. This is just something I have set up for the exercise, but what we are talking about here is, for example, digits are codes like this. Okay, so 6611, that's a possible code, and we see that 6 is repeated twice, 6 and 6, and also 1 is repeated twice. So in this case, repetition is allowed. A counter example will be 1, 5, 3, 4. Here we have each of the 6 digits from 1 to 6, 1, 3, 5, 3 and 4. Okay, but here there's no repetition allowed. So what I'm going to do here is I'm going to look at this scenario here where repetition is allowed, the top scenario. So what I could do here is have my 4 cells, 4 vacancies. And what I can do here is just talk about how the digits get selected. Okay, so let's just say so when we're starting out and we want to fill in our vacancy, our first digit, we can pick any one of those 6 digits. Okay, now let's just say for argument's sake I pick out 3. Okay, what can happen here is that I can pick from any of those 6 digits. Sorry, I not meant to put that in there. I'm going to put that in there. And what I'm going to sort of say is we have 6 possible options there for that first digit. Okay. The next digit is again any one of these 6 options here. So this is the multiplication rule essentially. And I can pick any one of those digits again. So let's just say for argument's sake I go for 2 this time. Okay. And in this case, what I'm going to do now is pick any of those 4 digits, 4, and let's just say 4. Okay. So in each of these cases, what I could do is 6 times 6 times 6 times 6. There are that many. It's 6 to the power of 4 is the answer. Okay. Bit of calculator work. Actually, I'll just do that in my calculator. 6 to the power of 4. The answer is 1296. So the answer to the first question is, if repetition is allowed, how many possible options are there? And the answer is 1296. So 6 times 6 times 6 times 6. In other words, 6 to the power of 4. Okay. Now, that is repetition when repetition is allowed. But what happens when it is not allowed? Well, what we're going to do is start again. Okay, so and I'm just going to get rid of that there. Okay, so when I'm starting out here again, let's say for argument's sake I could pick one of these 6 digits. Okay, but there's 6 digits to choose from. Okay, so it's 6 times whatever's next. Okay, but let's just say for argument's sake my number here is 2, starts with a 2. That means I can't pick 2 again. That means that there's 5 options left for the next one. Let's just say for argument's sake it's 4 for the next one. Can't pick that one anymore. So I got 4 options left. 1, 3, 5 and 6. So that's 4 options for the third place. And let's just say for argument's sake I pick it's number 1. And then I have 3 options left to fill out the last one. And let's just say for argument's sake I go for 5. Okay, so when repetition not allowed, the number of ways we can pick out 4 digits from 1 to 6 when each digit has to be between 1 and 6 is what that number would be. 30 times 12 would be 360. Okay, it's when you multiply 6 by 5, you get 30 by 4. Okay, yeah, so 360. Sorry, 360 is the answer. 360, not 630. 360. So when repetition is not allowed, there's only 360 possible ways you can pick out 4 digits. So that is the first question. When repetition is not allowed, how many codes are possible? Let's just look at another one here. An ordered sequence of 4 digits is formed by choosing digits without repetition from 1 to 7. The total number of sequences, okay, how many ways you can pick them out, when repetition is not allowed, okay. So, let's do that one. And what we would have here to start off is we have, these are options here, 1, 2, 3, 4, 5, 6, 7. Okay. Now we're going to sort of make room for have 4 possible digits. Okay. So just like we've done the last time, the answer would be 7 times 6 times 5 times 4. Okay. Working that out, you would get, that's just a sort of the same logic from the last time round, just with just a different number of options for each vacancy, so to speak. The answer to the first one there is, just pause this for a second and just get my calculator out. The total number of ways is 840. Okay, so there's 840 ways you can pick out 4 digits from 7 when repetition is not allowed, from those 7 there. Okay. Now, the next thing is the total number of sequences that begin with an odd number, okay, and also the total number of sequences that end in an odd number. Now, this requires a sort of a different sort of an extension to the sort of approach being taken, this sort of blank space approach. So what I'm going to do is actually start this out again. So we have 4 vacancies, and we can pick from these 7 options. Okay. Now, first off, there's going to be a constraint here. We have to have an odd number here. Okay. So to pick out the first digit, we could have a 1, a 3, a 5, and a 7. Okay. So rather than having 4 possible options, we have only we have to start with we only have 4 options to use for the first item. Okay, so it must start with one of those. Okay, so let's just say for argument's sake we have picked a 3. Okay, so 3 has been picked. Now there are 6 left and there's no more constraints. Let's just read the question there again. It's not the question, this is the question. Determine the total number of sequences which begin with an odd number. Okay, after we have picked out our odd number as for the first vacancy, we can pick any of the 6 remaining ones. Okay, so let's just say we pick a 4. That's gone. Now there's 5 left, and let's just pick a 6. So times 5 times 4. Okay, so 4 times 6 times 5 times 4, that is, the answer there is 400. Let's just say for argument's sake we pick a number here like, 3462. And there are 480 ways that we could pick out a number that begins with a odd number and no repetition, and all the numbers are between 1 and 7. So the key thing there is that we started off looking at this constraint here. Okay, that's the first thing we do when there was some sort of constraint applied to one of the vacancies. We're going to do the same thing again now. Okay, and in this question here, that's not what I'm working on. I was working on these the same day, if you're familiar with what I'm looking at. This is the other question here, and it is essentially what happens here in this last part is that it ends. It must end in an odd number. So there's a constraint here right at the end. Okay, so the number of sequences which end in an odd number. Okay, so what we're going to do is sort of start where there is a constraint here right at the end. Okay, So we could pick from 1, 2, 3, 4, 5, 6, and 7. Okay. Now there must be an odd number that goes in here. So we'll look at that first. So essentially what we must do is pick out one of those 4 numbers there. So we're going to pick out, there are 4 possible ways we can get end on an odd number. Okay, so let's just say for argument's sake our number ends with 7. Okay, now let's go back to the start. So we have we sort of put in our constraint. Sorry, it has to be there are 4 possible options there. Okay, and it ends, so our number ends with a 7. So there's 6 possible options here, so we're just going to go back to the start. We can pick any one of those 6 numbers there. So let's just say we pick a 5 to start with. Now there's 5 options left. Okay, so let's just say for argument's sake I pick a 3 for my next one, and then there are 4 options left. Okay, and in this case there is going to, let's just pick a 2 there. Okay, so in this case the number of options that must end with a odd number is also 480. Okay, so the number of ways that ends with an odd number is 480 also. So that is that question there. Okay, it's not actually asked here on this question sheet, but what I'm going to do now is how many must begin and end with an odd number. Okay, so let's go to a new page here. So we have our 4 vacancies. Okay, so the constraint is here, then here. Okay, so and we're picking from 1, 2, 3, 4, 5, 6, 7. Okay, so I'm going to start where the first constraint is, and there are 4 possible numbers we can pick for the first vacancy. Okay, so there's 1, 3, 5, and 7. So there's 4 numbers we can pick for there. Okay, so let's just say for argument's sake we pick a 3. Okay, now there are 3 odd numbers left, and one of them must go into the last vacancy. So there's 3 possible options that go in there. So I'm going to pick the 7 for that last vacancy just to sort of demonstrate. Now so we've sort of looked after all the constraints. Now we can just go to all the remaining vacancies and work from left to right. We have 5 possible options for the second one, and let's just say we go for 4 there, and then 4 possible options for the remaining one. Put that one in there, and what we would pick it for that one, we pick a 2 for that one. So we've picked out 3, 4, 2, 7 as a sort of prototype number. So anyway, how many ways can we have a number like this where it begins with an odd number, it ends with an odd number, there's no repetition, and all the digits are from 1 and 7? This is the number of ways. It is 20 by 12. It's 240 essentially. Working that number out, there are 240 ways that you can start with an odd number and end with an odd number for this question. So that's just going a little bit beyond what has been asked there. An ordered sequence of 4 digits is formed by choosing digits from that set there. Okay. An ordered sequence, sorry, they don't have to be in order, by the way. Sorry, they don't have to be in ascending order. 3, 4, 2, 7. They just can any sort of the ordered sequence. Just something that just sort of somebody I just thought of something that somebody asked me once. It doesn't mean that they have to be in ascending order. It doesn't mean that they have to be one higher than the next. It doesn't mean that to do an increasing order and like that. It's just an ordering there. Okay, so sorry, just sort of that through somebody I was talking who asked me about this once. Okay, so A PIN number is formed by choosing an ordered sequence of 9. So there we have it all again. Repetitions not allowed, but numbers beginning with 1 are. How many different ways can we pick it out? That's just in your head. That is 10 digits altogether, and there's 4 options. So that's going to be 10 by 9 by 8 by 7. Okay. And how many will be odd? How many will be greater than 800? Greater than equal to 8,000? And how many will be greater than or equal to 8, or odd and greater than or equal to 8,000? So this is a bit of a tough one now. So I know we're a good bit into this, but I'm going to sort of finish on this one. I'm going to sort of skip the first one there. It's pretty easy. The answer is simply 10 by 9 by 8 by 7. Working that out, you should get the right number there. So that's the first one. The second thing I'm going to do is we're just going to look at, so we have 0, 1, these are our possible options here. Oops, getting a bit ahead of myself. 5, 6, 7, 8, 9. So when we're trying, this is for this first one here, how many numbers will be, sorry, actually I'll work on this one, greater than or equal to 8,000. Okay, so this one, the only possible, I'm going to work on this one first, where it's greater than 8,000. In this case, there's only 2 ways we can start off our PIN number such that it's greater than 8,000. The first digit has to be 8 or 9. Okay, so it's only these 2 possible options, or one of these 2 numbers can be our option here. So there's only 2 ways we can start off a number such that it's greater than 8,000. It starts with an 8 or it starts with a 9. Okay, let's just say for argument's sake we pick out 9 there. That's gone. So the number starts is 9, for example. After that, we can pick out any of the 9 remaining numbers for the second one. Let's just pick a 5. And then any of the 8 remaining numbers, let's pick 4. Oops. Then that should be a blue pen there. And then any of the remaining 7 numbers. Okay. So the answer, how many ways can we get more from 0 to 9 using those digits? How many ways can we get? Let's just go for 0 there for the last one. My pen coloring is all over the place. So 9, 5, 4, 0. That would be, let's say, the sort of an example of a number selected. So how many ways are there of getting a number greater than 8,000? It's 2 times 9 times 8 times 7. Let's work that out. I make that to be 2 times 9 times 8 times 7. I'm going to put this in a black. The answer is, start again, 1,008 ways. Okay, so the answer to the second one, how many numbers will be greater than or equal to 8,000? There are going to be 1,008 ways. Odd is sort of similar enough. We just pick the last constraint and so on. That one is easy enough. Okay, so this next one is the tough part. This one requires a lot of lateral thinking. Okay, so I am going to finish off on this last one here. It has to be odd and greater than or equal to 8,000. So what we're going to do here is, this is greater than 8,000 and odd. Okay, so what I'm going to do is break it up into 2 sub-problems. Okay, and in the first case, it starts with 8. It has to start with 8, and in the second case has to start with 9. Okay, the reason is this, for both scenarios, and both of these 2 scenarios, there's a different amount of odd numbers available for the end. So in this case, there's only one way you can start it with 8 by picking out digit 8, and likewise there's only one way you can start with 9. Okay, by starting with there's only one option for 9 for that vacancy. Okay, now when it starts with 8 and it's odd, that means that there are 5 of these possible digits here. So I'm just going to sort of pick out the digits that are available, such that the number can be odd. So it can be 1, it can be 3, it can be 5, it can be 7, and it can be 9. So there's 5 possible options for when we finish, so that for when it starts with 8, that it can finish with an odd number. And beyond that, there would be, we've started with 8, we've picked out an odd number for the end, so there's 8 digits for the second vacancy and 7 digits left for the third vacancy. Okay. Now the second scenario, it starts with a 9. So let's just go back here. When we start with a 9, we can't pick it again. Okay. That's where things get different. This one takes a little bit of lateral thought, and breaking up the problem is the right thing to do. So in this case, we've only got 4 options left. And what are those 4 options for the last vacancy? 1, 3, 5, and 7. We can't use 9. But once we have starts with a 9 and it ends with an odd number, one of the other odd numbers, we can put in anything that we like left. There's should be 8 digits left for the second vacancy and 7 digits left for the third vacancy. So essentially, the number of ways it could start with 8 and be odd, and the number of ways it could start with 9 and be odd. So essentially what we've got to do is multiply out both of those numbers there. That is going to be equal to, for the first case, 8 times 7 times 5. Better not work that out in my head. I'll just get my calculator. That is 280 ways, so that's 280. And then this will be 224. So the answer is those two numbers together. You can separate the problem out into 2 sub-problems, and the overall answer is going to be 504. Okay. So that's counting problems and a useful approach to take with these type of problems. I'm going to leave it there. That's a lot of work done.